All right, transforming linear functions. This lesson is going to be kind of the building blocks for the rest of the unit. We're going to talk about a very important translation equation that turns out that it's the same for all of our functions. So, here we go. Basic definition of a transformation is going to change the size or the position of a figure or graph. Great news! You've already done that in geometry. We talked about reflections, dilations, stretches, shrinks, rotations, all that fun stuff. We're going to talk about it again, but this time instead of doing a figure like a square or a rhombus, we are now doing it to our equations. We're going to talk about family of functions. Each family has to have a parent function. So for this lesson, we're talking about linear equations. So the parent function is that basic function. It's the building block. Well, our basic function is y equals x. So that's our parent function. Then, anytime we do a transformation on the parent function, that becomes part of our family of functions. And there's infinitely many possibilities there. We could have y equals 3x plus 2. Y equals negative x. Y equals 1/4 x plus 5. Any of those can be considered part of the family of functions. So, remember I said there's a very important equation we're talking about? Well, here it is. Y equals a times x minus h plus k. This is very important. It will only change based on the different equation, or not equation, function that we are talking about. But a, x, h, and k will all remain the same. But for today, a way you can think of this is, we've talked about the point-slope form. Okay? We can think of this form and rewrite it so that we have the plus y1 on the other side, and that's going to give us the same thing for this translated function for a linear equation. So let's talk about what does a, h, and k stand for. The h of your function is the horizontal shift. Now, something very important happens this whole time. H is a liar. I don't know how many times I'll say that, but H is a liar is very important. Whenever you see H, we have to take the opposite value. Once you've taken the opposite of what you see, then know that if H is positive, it goes right. If H is negative, it goes left. K stands for the vertical shift. K is not a liar. We take it as we see it. If it's positive, we go up. If it's negative, we go down. We'll get to the A in just a second. The next thing we're going to talk about is the reflections. We have two reflections. We can reflect over our y-axis. We can reflect over our x-axis. If the negative is inside your parentheses, then that's when we reflect over the y. If the negative is outside of our parentheses, that's when we reflect over the x. So the x is easier to see when we talk about parabolas. You're just flipping it upside down. In the y, you're still kind of flipping it upside down, but it's like we're folding that y-axis over and just kind of, remember those little butterflies you used to make in kindergarten? You painted one side and you flipped it, gave you a mirror image. That's kind of what we're doing with these reflections. So let's practice this basic stuff for right now. So we have this function, f of x equals x minus 2. We want to do a horizontal translation, right 3 units. Okay, horizontal. Is that h or k? If you said H, you are right. Easy way to remember it, H stands for horizontal. Perfect. Now, because it's right 3 units, when we put it into our translation equation, what do we have to do? That's right. H is a liar, once again, so we're just going to plug in the 3. So that means our f of x now is going to be equal to x minus 3 minus 2. Because h is a liar, so it's negative in our equation, positive when we just talk about it. All right. This one's a little trickier because it's now f of x equals 3x plus 1. We want to translate this 2 units to the right. This is still which kind of translation? It's horizontal, so it's going to be h. So we have f of x, oh, sorry, we were calling them g of x. So g of x equals, we're going to think of that 3 as being outside of our parentheses. So it's going to be like 3x, and now we have minus 2 plus 1. That's all there is to it. Now, those were basics. We will get to doing multiple translations in one equation. Let's take a look at this. We've got a linear function in this table, and we need to reflect it across the x-axis. Now, let's first find our equation. Shouldn't be too bad. We need to just do basically the change in our x, which this increased by 2, this increased by 2, over, well not over, sorry, and our change in y, which is increased by 1, increased by 1. Now, slope we talked about was our y2 minus y1 over x2 minus x1. So we put our y over our x's. So this is our slope. Well, we talked about intercepts. This is your y-intercept. So we now have the equation y equals 1/2 x plus 1. And this is a function, so we can go ahead and say f of x. Oops, let's see. Yep, f of x. Make sure I named it right. Had to read my problem. So now, we want to reflect this across the x-axis. Well, if you remember, it reflects across the x-axis when we are outside of our function. So, in order to do that, we are going to say g of x, and remember we are outside of our function. So we're going to put parentheses around our function and be done. And you don't even have to distribute it. You can leave it just like that. Okay, now the tricky parts. Compressions and stretches. It's a change in the slope of this linear function. If the line becomes steeper, then we have stretched it vertically or compressed it horizontally. So, we would look at this figure here. Our original equation is the blue one, and we have stretched it vertically, so our red one now is steeper. What that means is we have times it by an a out in front. So that's what happens when our a is greater than 1, we are stretching it. If it's between 0 and 1, then we're going to compress it towards the x-axis. Think of it as a slope. Okay, if you have a slope of 1/4, we would go up 1. So let's say we start here, we go up 1, and then we go over 4. Okay, now in the same thing, let me change my color. Let's say we had a slope of 3 over 2, starting at the same point, we go up 1, 2, 3 over 2. You can see that this is a steeper slope. So the larger the number, the steeper it is. The lower the number, the flatter it will be. Okay, so if the line becomes flatter, the function has been compressed vertically or stretched horizontally. So when b is greater than 1, so yes, b is not in our translation function, but we can still use it. B is like saying that we have that fraction, that 1 over 4. These are going to take a little bit of getting used to, but I'm sure you'll do fine. Okay, so let's give this a horizontal compression to f of x equals negative x plus 4 by a factor of 1/2. So, a horizontal compression. We are going to have that g of x is equal, so we have this negative still is going to be out in front. Because this is a horizontal compression based on the rule that we just looked at, we're going to have a 1 over b. Well, our 1 over our b, so let's put up here, b is equal to 1/2. So we have 1 over 1/2, we'll simplify that here in a second, times our x plus 4. Well, 1 over 1/2 is like saying 1 divided by 1/2, which is the same as saying 1 times 2 over 1. So it's equal to 2. So then g of x is equal to negative 2x plus 1. Okay, let's try a vertical compression to f of x equals 3x plus 2 by a factor of 1/4. Now, if we look at our notes for vertical compression, that is our a. So we're going to have g of x equals our a, which is 1/4, and then 3x plus 2. And you don't even have to distribute it. Now, to this point, we've looked at only doing one change, but you can also combine them. So we want to change f of x equals 3x. We want to make it go left 6 units, followed by a horizontal stretch by a factor of 4. Okay, so first thing we're going to do is we're going to shift it left 6 units. So if we're going left 6 units, that is our h, and left means negative 6. So let's first do this. So we have that g of x is going to equal 3, and then remember we said that we do parentheses, x minus 6. Whoops, opposite. So x plus 6. H is our liar. So now we are going to horizontally stretch this, which means we have to do our 1 over our b. Well, our b is 4. So we now have that g of x equals 3 times 1 over 4x plus 6. Now, don't worry if you're still a little confused on the compressions and the stretches. We are going to look more at that. It takes just a little bit of time to get used to that. Okay, we're going to skip that slide actually. So in summary, we showed how that we can change an equation of a line. There's many different formulas. We just have to remember our general formula of y equals a times x minus h plus k. This will be the same for all of them. So in class, we're going to look at a few word problems as well as talk a little bit more about our vertical compressions and stretches and all that fun stuff.